Yeah, hello and welcome. Today we are going to look at a step-by-step of proving the cosine rule. What is the cosine rule here? The cosine rule states that if I taking a reference on the length a, that will be a squared to be equal to b squared plus c squared minus 2bc cos a. Okay, we can also have b squared equals a squared plus c squared minus 2ac cos B. But let's put the reference on this. How do you prove this one? We are going to look at the step by step of doing this. So the first thing to do is to draw a triangle. This one is free schedule. So is that okay? Second thing, let's name this triangle. Now because I'm making a reference on A, I'll bring the A here. Okay? Then I have my B here. I have C. Now this A, the angle here too will be A, the angle here will be B, the angle here will be C. Now because this side is A, the opposite of this becomes the small a, that's the length A. The opposite of B becomes the length B, and that of the C becomes that. Now let's look at something here. Okay, so this one, I've created a height for this triangle. And for this height, let's name it H. Okay, now we know that from point A to point B, it is what? C. Let me write it here. Now let's also look at from A to this side, and also look at from this place. If here is D, let's name that place D. From D to B, let's look at what you are going to do there. If from here to this side is C, and this side alone is C, what will be here? It means that this place is going to be, so this side alone is X. Let me replace here by X. Here is going to be C minus what? X. What I'm saying is that let's say if from here to here is 10, and only this place is 3, means that this place will be what? 7. You simply subtract the 3 from what? The 10, that gives you this. So if from here to here is C and here is X, it means this place will be C minus X. Good. Now let's see what we can do. We know that from this place, using Pythagoras theorem, then also considering triangle ACD, okay, this side is D. Considering that triangle, we can say that B squared is equals to X squared plus H squared, right? Let's make H squared a subject, so that I have H squared equals B squared minus what? S squared. Let's name it equation 1. Let's also consider triangle DBC. Okay, DBC. What do we have? We have A squared equals H squared plus C minus X squared. Is that okay? So let's expand this one. A squared equals H squared plus C squared minus 2CX plus X squared, right? If you expand this is what you get. Now here, let me make H squared a subject. Means that my H squared will be equals to A squared minus C squared plus 2CX minus what? X squared. Let's name this one equation 2. So let me divide the board. At this point, let's equate equation 1 and equation 2. You can see that if you say that equation 1 is equal to equation 2, it means that our a squared is equals to h squared. From equation 1, the h squared is b squared minus x squared. And this is equals to a squared minus c squared plus 2cx minus x squared. So this is what we have. But you want to get something like this. So let's try to make a squared a subject. So if I want to make a squared a subject here, I'm going to have a squared is equals to b squared. Remember this one will cancel this, because if I bring the negative s square here, you can't negative s square, positive s square, that goes to 0. So that's what you have there. So we have b squared plus c squared plus 2cx. What I've just done here is that I've maintained the a squared and I've moved whatever that is here to this side. So that's what I have this. Now, still, we have not achieved, we have the c here, we have the 2 here, but we don't have b cos a, okay? So let's visit the diagram again. Let's consider, you see, our focus is on a. If we are to prove for b, like b squared equals the other side, the focus will be on b. If it is c, the focus will be on c. Let's consider this one, the a here. That's a triangle ACD. You consider that triangle, you realize that cos A will be equals to cos A will be equals to opposite. What is the opposite of this? That's H over, sorry, cos is adjacent over hypotenuse. So adjacent is X, not H, over the hypotenuse, which is B. I beg your pardon for that. So my X here becomes cos A times what? B. Is that okay? So now let's go back to this place and you substitute wherever you see x with cos A times B or B cos A. So that is going to be a squared equals b squared plus c squared plus 2c. But remember, multiplication is commutative. So let me bring the x first. Our x is b cos A. So b, then there's c here, c before the cos A. So this becomes the how do you call it, the proof for the cosine rule. Thank you very much.